For more than 4 decades, a small spacecraft has been moving steadily away from everything familiar. It drifts further each year from the warmth of the Sun, slipping beyond the boundaries of the known and into a region once confined only to theory. It left behind the planets one by one, crossed the fading edge of solar influence, and continued outward into a domain no human-made object had ever reached before. That spacecraft is Voyager 2, a machine born from ambition at a time when technology was limited, but imagination was vast. It was launched in 1977 under NASA's Deep Space Exploration program, built not as a mythic Voyager, but as a carefully engineered scientific probe designed to visit the outer planets and send data back home. Its original mission was simple in design, but monumental in consequence. It would fly past Jupiter, Saturn, Uranus, and Neptune, collecting images, measurements, and readings that no human eye had ever seen before. After that grand tour, it was expected to fall silent, its power fading as its distance increased, its instruments slowly shutting down as it drifted into darkness. It was built for a journey measured in years. Not decades. Certainly not half a century. And yet, it endured. As Voyager 2 moved outward, it transformed our understanding of the outer solar system. It revealed Jupiter's violent atmospheric storms, where massive cyclones churn endlessly in bands of colored clouds. It showed Saturn's delicate and complex ring system, made not of solid structures, but of countless icy fragments orbiting in precise balance. It gave humanity its first detailed glimpse of Uranus, a tilted and mysterious world rotating on its side, unlike anything previously imagined. And finally, it reached Neptune, unveiling deep blue winds and dynamic storms raging in an atmosphere far from the faint sunlight that reaches it. Each encounter was a revolution in planetary science. But Voyager 2's journey did not end there. After completing its planetary mission, it continued forward toward a boundary that had never been directly crossed before: the edge of the Sun's influence. Around our solar system lies a vast, invisible bubble called the heliosphere. It is formed by the constant outward flow of charged particles from the Sun, known as the solar wind. This bubble acts like a protective shield, deflecting a significant portion of high-energy radiation from deep space. For decades, scientists imagined this boundary as something gradual. A slow fading of solar influence into the interstellar medium, like a shoreline dissolving into the ocean. But Voyager 2 revealed something very different. As it approached the outer edge of this region, its instruments began detecting subtle but meaningful changes. Particle densities shifted. Radiation levels began to fluctuate. Magnetic field directions changed in ways that were not gradual but abrupt. Then, in a moment that redefined our understanding of cosmic boundaries, everything shifted. Voyager 2 crossed the heliopause. One moment it was inside the Sun's protective bubble. The next, it had entered interstellar space. This was not a smooth transition. It was a distinct boundary, sharp, structured, and physically meaningful. A separation between two different cosmic environments. Inside the heliosphere, the Sun dominates everything. Its magnetic field shapes particle motion, its solar wind pushes outward, and its influence defines the environment of all planets. Outside it, everything changes. Radiation becomes stronger and more chaotic. Magnetic fields interact with the broader galaxy. Charged particles move in complex, unpredictable flows. The environment resembles less a void and more a vast invisible ocean, filled with currents, turbulence, and large-scale cosmic weather patterns driven by distant stars and ancient supernovae. This discovery forced scientists to rethink the nature of our cosmic neighborhood. The solar system is not simply drifting through empty space. It is embedded within a structured environment, shaped by both solar and galactic forces. The heliosphere is not just a fading influence, It is a dynamic shield, constantly expanding and contracting in response to the Sun's 11-year activity cycle. During periods of high solar activity, stronger solar winds push the heliosphere outward, strengthening its protective boundary. During quieter phases, it contracts, allowing more interstellar radiation to enter the inner solar system. Voyager 2 crossed during one of these quieter phases, offering a rare and valuable glimpse into how fragile and variable this protective bubble can be. Beyond the heliopause, Voyager 2 encountered a region that defied old assumptions. Interstellar space, once imagined as empty and silent, turned out to be anything but. Instead, it revealed structure. Plasma flows fluctuate like currents in an invisible sea. Magnetic fields stretch across vast distances, interacting in complex patterns. Radiation levels rise and fall in cycles, suggesting large-scale influences shaping space itself. It is not emptiness. It is environment. A kind of cosmic weather system shaped by distant supernova explosions, galactic magnetic fields, and long-forgotten stellar events that continue to ripple through space. One of the most surprising findings came from magnetic measurements. Scientists expected the boundary between the Sun's magnetic field and the galaxy's field to be chaotic, turbulent, and disordered. Instead, Voyager 2 detected a smoother transition than predicted. In some regions, the alignment between fields appeared unexpectedly structured. This raises profound questions. Is the solar system moving through a region of space that already has underlying structure? Or has the Sun, over millions of years, shaped its surrounding interstellar environment more than previously believed? Either possibility suggests a deeper truth. Space is not isolated or random. It is interconnected. Then came another moment that reminded scientists of how fragile exploration can be. In 2019, Voyager 2 suddenly lost communication with Earth. For several hours, the signal vanished. Data transmission stopped. The spacecraft appeared silent. For a brief moment, it seemed possible that humanity's most distant active probe had finally reached its end. But the silence was temporary. Communication resumed, and the spacecraft returned to normal operation. Engineers traced the issue to aging systems and temporary errors in onboard handling, expected behavior for a machine operating far beyond its original design lifespan. Still, the data surrounding that interruption revealed unusual activity. There were spikes in charged particle energy and subtle disturbances in the electromagnetic environment. Some scientists suggested Voyager 2 may have passed through a region of heightened plasma activity or encountered distant shockwaves traveling through interstellar space. Others proposed more uncertain possibilities, localized structures or phenomena not yet fully understood. The truth remains open. Attached to Voyager 2 is one of humanity's most symbolic creations, the Golden Record. A carefully curated collection of sounds, images, greetings, and music from Earth. It was designed as a message, not for us, but for anything that might one day encounter it. At the time of its creation, it was an act of optimism. A symbolic gesture saying, "We exist, and we reached this far." Now, as Voyager 2 moves beyond the Sun's influence into true interstellar space, that message carries a deeper meaning. It is no longer just symbolic. It is physically present in another cosmic environment entirely. A record of Earth drifting between stars. And so Voyager 2 becomes something more than a spacecraft. It becomes a marker of presence. A proof that a technological civilization once reached beyond its home star and into the galaxy itself. Even now, it continues its journey outward. Its power slowly declines. Its instruments will one day fall silent forever. But its motion will not stop. It will drift through the galaxy for millions, perhaps billions of years, long after Earth has changed, long after human civilization has transformed beyond recognition. What it has already achieved is extraordinary. It transformed theoretical boundaries into observed reality. It revealed that the edge of our solar system is structured, not abstract. It showed that interstellar space is dynamic, not empty. It demonstrated that even at the edge of the sun's influence, there is complexity, motion, and interaction. And perhaps most importantly, it revealed something about us. From a small world orbiting an ordinary star, humanity built a machine capable of crossing into interstellar space. A machine that continues to explore, measure, and transmit knowledge across unimaginable distances. Voyager 2 is not just traveling outward. It is carrying a question that has followed humanity since the first time we looked up at the night sky. What lies beyond? And somewhere in the deep silence between stars, it continues to move forward, through a universe that is not empty, but vast, structured, and still waiting to be understood.